As you go across a period on the periodic table, the number of valence electrons is increasing. The number of protons is increasing by 1. The number of neutrons fluctuates. As you go up and down a group, the number of valence electrons stays exactly the same. However, the number of orbitals or quantum levels increases by 1. Now, in group number 1, period number 1, you have 1 orbital. Number 2, you have 2 orbitals. 3 orbitals. 4, and so on and so forth. By the time you get down to the bottom, 2, 3, 4, 5, 6, 7. So as you go down a group, the atomic radius is increasing. Now the atomic radius is a little bit different than a normal radius. The atomic radius is technically defined as the distance, or half of the distance, from one nucleus to the other, which is basically kind of like just saying the distance from the nucleus to the edge of the atom. However, the technical definition is from one nucleus to the other divided by 2. For our purposes, it doesn't matter. Now, as you go down, the atomic radius is increasing because you're adding more orbitals. As you go across, you are adding more and more and more electrons. Those electrons, by the time you get over here, they have a full valence shell. The more electrons you have, the smaller the atomic radius becomes. And this is kind of a weird concept to think about, but just think of it this way. As you add more electrons, it kind of has a shielding effect, and it draws those electrons closer and closer and closer to the nucleus. Think about it this way. If you're carrying a shopping bag, or a book bag for instance, one book bag, I can carry it way, way out here. As I add more and more book bags, now I'm not that brolic, but as I add more and more book bags, my radius is going to get closer and closer and closer to my body until I'm carrying a whole ton of book bags. I'm going to be closer to my body like this. So it's kind of the same thing with electrons. One electron, far out from the nucleus. Many electrons, it's going to be very, very small. Now you don't really have to remember this because all this information is provided for you in Table S. So if you can't remember that, don't worry about it. Look in Table S. Atomic radius and also electronegativity. All that electronegativity means is how bad an atom wants an electron. So when we compare sodium and chlorine, 1, 2, 3, 4, 5, 6, 7, sodium, whose electron configuration is 281, chlorine is 288, 287. Sodium doesn't want that last electron. That last electron, it wants to get rid of it. So it'll have a full octet underneath it. Chlorine wants to pick up an electron. It needs another electron to complete its octet. So it is said that chlorine and elements on the right side are electronegative, and elements on the left side have a low electronegativity. The most electronegative element is fluorine, with an assigned value of 4.0. And an element like, for example, neon, with 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, it doesn't want any electrons. So it does not have any electronegativity. All of the noble gases have no electronegativity values. All of the halogens have high electronegativity. And all of the alkali metals have low electronegativity. And this is related, again, to their atomic radius. Thank you.